We are switching gears to vectors, and so we're still doing some things with trig, but the things that we're doing now have more to do with like real world things rather than kind of this theoretical math with sines and cosines and tangents. And so today's focus is solving for the magnitude and the direction of our vectors. And so, first things first, a vector is a directed line segment with magnitude or a length and a direction or a slope. So, like deciding which way we're pointing. And what we're going to see today is we're going to see component form today, and we're going to see linear combination form today, which is the x and y, and the x and the y. So depending on which way you're seeing it, it's still the x and it's still the y. X is first, y is second. And so what we're seeing here is your x value. You have an x value and you have a y value. And so you're going from your starting point to your ending point. Pardon my not straight line. And so what's formed here, hopefully you see, is a right triangle. So the way that we are drawing this is exactly the same way we've been drawing right triangles on our unit circle for months and months. And so we have an x value distance and a y value distance. And so then this distance here would be my magnitude. And then the direction is my angle measure. And so hopefully this picture looks exactly the same as your picture has looked for months, that we have an x value, we have a y value, and we have a radius value or a hypotenuse, or today it has a new name and it's called the magnitude. And so the other thing that gets used a lot is this word component. And so in component form, you have the x value and you have your y value. So today we're going to be drawing pictures of our vectors, and so knowing where that x value is, knowing where that y value is, knowing where that magnitude is, and knowing where the angle measure is going to be really helpful. And so if you need to pause it here to copy these notes, go ahead and pause now, and I'm going to keep going. Okay, and so our vectors could be going in a positive direction. They could be going in a negative positive direction. They could be going in a negative direction or a positive negative direction. So you could be drawing it here, you could be drawing it here, you could be drawing it here. And so each of these vectors are going in different directions, and so in quadrant 1, your angle measures should be between 0 and 90. Quadrant 2 should be between 90 and 180, 180 and 270, and 270 and 360. You also could have a vector that goes directly to the right, directly up, directly left, or directly down. And so any angle measure, 0, 90, 180, 270, 360, or anything in between, any of those angle measures are possibilities. And so we're going to look at each of these situations today. Okay, so when you're given x and y, the way to find the magnitude is hopefully something that you've seen before, Pythagorean theorem. It's x squared plus y squared equals your magnitude squared. And this is just the symbol for magnitude. So anytime you see the double bars around your letter V or your letter for vector, or whatever your vector's name is, it could be any other letter, could be A or B or C or X or Y or Z. Usually we don't use X and Y because of X and Y already being something else, but it could be anything. And so x squared plus y squared equals magnitude squared. And so to solve for our magnitude, we square root both sides, And so it's the square root of x squared plus y squared. But really, big picture, this is just Pythagorean theorem. Okay, and then to find your angle measure, just like we have used inverse sine and inverse cosine to find our angle measure in other situations, today we're given the y and the x value, and so tangent is the function that uses y and x, and so we're going to use inverse tangent. But in the calculator can't tell the difference between this plus plus or this triangle minus minus. And so what happens in each of these different quadrants is we have to do some special things. In quadrant 1, it's just the angle measure. So we do inverse tangent of y over x, and we get the right angle measure because the calculator lives in quadrant 1. In quadrant 2, we have to take whatever that angle measure is, because it'll be this triangle over here, and so the calculator will give you a negative angle, and you have to add 180 degrees to that to put it in the right quadrant so that your direction is going the right way. In quadrant 3, we're going to take that angle measure and we're going to add 180 because we need to take this one and add 180. The calculator is going to give you a positive angle measure between 0 and 90, and you need to add 180 over here to get there. And then in quadrant 4, it's going to give you this angle, but it's going to give it to you in the negative form. So it'll be like negative 30. But we don't like negative 30. We like 330 degrees. We like the positive angle measure. So if we take 360 and we find its coterminal angle, remember that word, coterminal it's the same angle measure, the same stopping point that we had before. It's just one rotation around. So we have Pythagorean theorem and inverse tangent. Those are our two pieces of information that we're going to use today. And so pause here if you need to copy this down. Okay, so let's see. First things first, we're going to draw our picture so that we know where this is going to be. So a negative and a positive is going to put us in quadrant 2. So we have our arrow. It's going from 0, 0, left 3, and up 7. So negative 3, positive 7 gives me my two sides of my triangle. And so hopefully you see, like, oh yeah, Pythagorean theorem works great here. And so we'll just call this vector v. We want negative 3 squared plus 7 squared, and then we're going to square root that number. So we end up with the square root of 58 when we do that math. And then that is approximately 7.6. And so my magnitude is 7.6, and that goes on the hypotenuse spot. And then we want to know what angle measure is going to get us over here. And so to do that part, we need inverse tangent of our y value over our x value. So inverse tangent of y over x, that's what we're doing here. And that's going to give us negative 66.8. But we don't want the negative angle measure. This is giving us this angle measure over here. We don't want that angle measure. We want the positive form of this. And so I'm going to add 180 degrees to negative 66.8 for a final answer in the correct quadrant of 113.2 degrees, and this is in quadrant 2, which is in the correct location. So we want our angle measure to be in quadrant 2, and we want our magnitude to be longer than both x and y, and 7.6 is that for us. And so then this is the linear combination version of this. And so this one is a positive x and a negative y, and that's going to put us in quadrant 4. And so then the x value side is 10 and the y is negative 15. And so same thing on this one, we're going to use Pythagorean theorem. So 10 squared plus negative 15. So make sure that you put those negatives, anytime you have a negative, you put that in parentheses when you put it in the calculator. So 10 squared plus negative 15 squared. And remember, we have to square root that. And we get 325. And so the square root of 325 is 18.0. So here's our magnitude. And so 18.0 can go in the hypotenuse spot. And then we're looking for this angle measure that goes around to get us into quadrant 4. And so that's going to be inverse tangent. Every time we're finding an angle measure, we're using inverse of something, inverse sine, inverse cosine, inverse tangent. And so it just makes the most sense for us to use inverse tangent because we have y and x. And so inverse tangent of negative 15 divided by 10 gives us negative 56.3. But we want it in the same location but positive. And so in quadrant 4, we add 360 to that angle measure. So plus 360. And that gives us a final angle measure answer in the correct quadrant of 303.7 degrees. And so this is my magnitude. And this is my direction. Good luck!